About 2/3 of our body weight is water. Most of the reactions in our tissues occur in water, so we need to understand this substance in great detail. We can imagine the molecules in liquid water tumbling around, colliding, and attracted to one another by hydrogen bonds. Occasionally, two molecules will collide with sufficient energy for a hydrogen ion to be lost from one molecule to another. So all aqueous solutions contain three different species: the water molecule, always in highest concentration; the hydronium ion, a very reactive ion; and the hydroxide ion, also a very reactive ion. The equation for the reaction can be written as follows. In pure water, the reaction is at equilibrium, and the concentrations of hydronium and hydroxide ions are equal and very low. Water is a very weak acid and a very weak base. A solution of iron 3 nitrate is quite acidic, but how are all the hydronium ions formed? See how much easier a water molecule can remove a hydrogen ion, or proton, from a water molecule bonded to iron 3. The iron 3 makes its bonded water molecules more acidic by weakening their OH bonds. See if you can identify where the hydrogen ion was lost in the deprotonated complex shown below. The equation for the proton exchange reaction can be written as follows. Solutions containing other metal ions of high charge and small size, like chromium-3, are acidic for the same reason. Aqueous ammonia is a good example of a base. In this solution, there are two opposing reactions with water. Occasionally, an ammonia molecule pulls a hydrogen ion from a water molecule, forming an ammonium ion and a hydroxide ion. Elsewhere in the solution, an ammonium ion collides with a hydroxide ion to reform an ammonia molecule and a water molecule. So aqueous ammonia always contains ammonia molecules, many more water molecules, of course, ammonium ions, and hydroxide ions. Let's look at those two reactions again at the symbolic level. The NH3 molecule pulls an H+ ion from a water molecule. Forming an NH4+ ion and an OH- ion. The reverse reaction involves an NH4+ ion donating an H+ ion to an OH- ion. To reform a water molecule and an NH3 molecule. Even though these reactions are at equilibrium, the concentration of ammonium and hydroxide ions is much lower than that of ammonia molecules, which in turn is much lower than that of water molecules. Ammonia is only a weak base. Glacial acetic acid added to water produces an acidic solution. See how a water molecule is able to remove a hydrogen ion or deprotonate the acetic acid molecule. Only the hydrogen atom bonded to the oxygen is acidic. When the proton is removed, you're left with the acetate ion. The equation for the deprotonation reaction is written as follows. At equilibrium, the concentration of acetic acid is much higher than that of acetate and hydronium ions, so acetic acid is only a weak acid.